Hello, good morning, literary students. So today's topic is benzene, structure of benzene. Actually, the molecular formula is C6H6. So the structure C6H6, how we can give the structure of C6H6 is explained by this molecular formula, and how we can find out the structure. That is, the benzene structure is a planar nature. It is having the ring structure. It is having delocalized pi electrons in the benzene ring. So how it is formed? Who discovered this structure? And it is explained by this class, that is molecular formula. The molecular formula of benzene is as found by elemental composition and molecular weight determination is C6H6. That means the actual formula is C6H6 is found out by the elemental composition. How many number of carbons are present, how many number of hydrogens are present, that can be determined by the elemental composition. And according to that number of carbons and hydrogens, we can determine the molecular weight. Since benzene contains 6 hydrogen atoms less than the corresponding alkene, that is hexane. Hexane, if it is a single bonded such compound, it contains C6H14, that is CnH2n plus 2. It is simply contains single, not a double bond, it is single bond. Like alkanes, it shows C6H14, but it is giving the element by the elemental composition, it is giving C6H6. And coming to the chemical behavior observation, how it can behave, chemical behavior. Benzene behaves in a most remarkable manner in its chemical reactions. Unlike aliphatic unsaturated compounds, the typical reactions of benzene are the substitution reactions and not the addition reactions. So, from C6H14, it should not have any, simply it's not a single bond. If it is having double bonded compounds, alkenes like, if it is alkenes, they can react in a different manner. That means always alkenes undergo addition reactions. Double bond can be breakdown takes place and the addition type of reactions takes place. But here it is benzene is undergoing the substitution reaction, and only one atom is substituted in place of one hydrogen of the benzene. So it indicates it's the double bond is not like alkenes. And failure to undergo some typical addition reactions. Benzene does not undergo many addition reactions. Characteristics of aliphatic unsaturated compounds. Does not decolorize KMnO4 solution. Does not decolorize bromine dark. Does not act on halogen acids. So these three reactions indicate that if the alkenes are present, double bonded compounds are present, or unsaturation is present, they can decolorize the KMnO4 pink color to light color, and bromine is an orange color to light color, and it undergo addition type of reaction with HCl. H and Cl both are substituted. It undergo addition, but it doesn't happen. Only the substitution is takes place. That indicates that benzene is not behaving like a simple alkane, and benzene is not behaving like a double bonded compound, alkene. So coming to isomer number, benzene aids only one monosubstitution product. One chlorobenzene and only one nitrobenzene are known to exist. This fact clearly indicates that all the 6 hydrogen atoms of benzene are equivalent to one another. A number of structures as shown in below proposed from time to time. So the isomer number means it is having C6H6. So if the alkene type and alkane type, different types of hydrogens are there, they can go different types of substitution and they can give different isomers. If you take benzene in a test tube and you add chlorination, if it undergo addition, it can give chlorobenzene, and if it is undergoing simple alkane substitution, it can give dichlorobenzene, like that. But it is always giving only one chloro substituted benzene. That indicates that all the hydrogens are same. In benzene ring, all the hydrogens are same. So according to that, they propose some structures like this. 1, 2, 3, 4, 5. So here you can concentrate this. So we think we can give 6 carbons first and we can add 6 hydrogens. This structure is formed. Okay. But here is one double bond is there and one single bond is there. But according to our theory, isomeric number, only all the hydrogens are similar form. This is the carbon is attached to one single bonded carbon and one double bonded carbon. But coming to here, so if the substitution takes place on the benzene ring, what happened? This different types of substitution takes place. Diva structure. This is called Diva structure. This carbon containing hydrogen is different and this carbon containing hydrogen is different. So it can give two isomers. So it can be rejected. And see here, this is also containing 6 carbons and these are also 6 hydrogens. So according to C6H6 it is fulfilled, but it is having one single bond and one double bond. But according to our isomeric theory, this type of substitution is not possible. Single substitution compound doesn't give, so it can be rejected. And coming to here also 6 carbons and here also 6 hydrogens, but it is having alkyne and alkane. So different types of hydrogens are there. So they also give different types of additional compounds. Here also same. Unsaturation double bond is there, triple bond is there, and different types of hydrogens are there. On substitution it can give one chloro substitution and 5 chloro substitution. Different compounds are there. So that's why 2, 3, 4, 5 all are rejected. So first, before writing of this structure, just to concentrate on that, you have to write the structure as per C6H6. 6 carbons should be there, 6 hydrogens are there, and fulfill these double bond and single bond. And according to that, you have to practice more and more these structures. But all we can fulfill by this structure. All the hydrogens are same, but double bond and single bond is there. But this double bond is not proved by the K-manifold disappearance, Bowman disappearance. So how we can confirm this structure? So that can be done by the Kekulé. Kekulé is given two structures. Now structure 5 can be rejected since it would yield a isomeric monobromo derivative, 1 bromo and 2 bromo derivative. All hydrogens are not equivalent. Similarly, 2 and 3 are unsatisfactory, 1 and 4 among others are still possibilities. 1 and 4. So 1 and 4, why all the hydrogens are here same and CSC is there, same types of hydrogens are there. Mono substitution only takes place. But how we can reject this means it is doesn't having any alkene, it is having single bond and triple bond. So how we can reject means see here. Benzene is a isomeric. Benzene is 3 isomeric disubstitution products. The disubstitution products of benzene can exist in 3 isomeric forms: ortho, meta, and para. 3 dibromobenzenes are obtained on bromate of bromobenzene. So all the 3 structures are rejected by a simple monosubstitution basis. On monosubstitution, it should give the same type of compound. But all the 3 are not given. 1 and 4 is giving because of similar types of hydrogens are there. But we have to prove 1 is correct, 4th one should be rejected. How it is rejected? By disubstitution reaction. So first we have to monosubstitution, it can produce one bromobenzene, and again substitution it can produce dibromobenzene. So in this disubstitution it is giving the ortho disubstitution, meta disubstitution, para disubstitution. This fact further limits a choice of structure. For example, 4 must be rejected now. See here. At first glance, structure 1 seems to be consistent. This new fact, that is, we can expect 3 isomeric dibromo derivative, that is 1, 2, 1, 3, 1, 4. See here, this is the 1, 2 simple bromobenzene we have taken. Again bromination takes place. 1, 2 dibromo, 1, 3 dibromo, 1, 4. That is ortho, meta, para. This possibilities are takes place by the first structure. In 1858, Kekulé proposed that all the carbons are joined in benzene ring. So what it is explaining, this simple structure it is giving 3 dibromo substituted isomers, but the 5th compound which is having 6 hydrogens are similar, that is they are having alkane, it doesn't give these 3 isomers. It can give only 1-2 substituted compound, that's all. So that's why 6th one is rejected and the last structure is rejected and it can be proposed and it can be proved by the Kekulé. The only formula which received general support, the hexagonal formula, that is structure 1, and that is proved to be Kekulé in 1865. So the first structure is proved by the Kekulé. It is giving the 3 isomers, 1,2-dibromo, 1,3 and 1,4. Theoretically it is proved and practically it is proved. But some question is raised, that is, it showed all the hydrogen atoms to be equivalent and therefore justified the formation of the monosubstituted benzene. But Ladenburg in 1869 objected to Kekulé's structure formula on the ground that it should yield 4 substituted derivatives, 2 ortho, 1 para and 1 meta, as below. Theoretically, if the structure is like this, it can give not only 1,2-dibromobenzene, it also give 1,6-dibromobenzene. Theoretically, but practically it is giving what? Only 1,2, 1,3, 1,4. So theoretically this structure also possible. So why it is not explained by the Kekulé? So that can be explained by in further, that is, it may be noted that the 2 ortho structures differ in the positions of the related to double bond. Kekulé overcome its difficulty by suggesting that the double bonds were not stable in a state of rapid oscillation between 2 forms, that is 6th and 7th, as shown below. So these double bonds are not stable. It can be oscillated from this form to this form. They are interconvertible form readily. Why? Because means that is delocalization of electrons takes place. So the final ring structure is given by the Kekulé. So that is about the Kekulé structure and how the benzene structure is proved. This is the main important question generally they can ask. How you can prove the structure of benzene. Stability of benzene. Benzene is 135 cyclohexatriene. We would predict benzene to be liberate approximately 85 kilocalories per mole. When it is hydrogenated, when benzene is experimentally hydrogenated, 45 kilocalories mole is released. So actually it is having 3 double bonded compound. 3 double bonds are there. After breaking of 3 double bonds, it can produce 85 kilocalories theoretically, but practically only 45 kilocalories it is showing. So the difference between the amount of heat evolved and the calculated Kekulé structure is called resonance stabilization. The benzene is stable by 36 kilocalories per mole. So resonance theory or valence bond theory, to overcome the objections over Kekulé structures and to account for regarding benzene, resonance theory has been suggested. According to this, the structures of benzene is resonance that are interconvertible by electron shifts. That is, these 2 Kekulé structures interconvertible and the final structure is proved by this. So that's why only 1,2-dibromobenzene is formed, not 1,6 can be formed. Only 3 structures can be formed. So by this it can be proved. That is, the Kekulé structures 6, 7 meet the conditions of resonance, that is structure proposed only in the arrangement of electrons. Benzene is hybrid of 6, 7. Since 6 and 7 are exactly equivalent and hence same stability and make equal contribution to the hybrid. The stabilization due to resonance should be large, that is 36 kilocalories. The 6 bond lengths are identical. The bond length is 1.39 angstroms. So that's why benzene doesn't having double bond. So it doesn't disappear the KMnO4 and bromine color. It is having only the 1.39 angstroms of bond length, and all the in between all the carbons it is showing only 1.39 angstroms of the bond length. So the substitution reactions are mainly it undergo nitration, halogenation, sulfonation and Feldkraft reaction. This can be discussed in the next class.